we're trying to find a solution to provide consumer with more good tasty food, but at the same time not like consume too much sugar or not like have this bitter perception while they consume a very healthy food. So we're trying to use flavor chemistry to balance that. We focus on the bitter inhibitor or bitter masking compounds. So those compounds, when they mixed with the food products, they somehow could masking this bitter perceptions.
We identified a need that we had for a new respiratory muscle training device to treat patients that have respiratory weakness. There's many patients that, for a variety of reasons, end up with weak breathing musculature. Sometimes to the point where they end up on a life support machine. Sometimes it's not as serious. So then from a rehabilitation standpoint, we need to strengthen their muscles of breathing. And we do this by a form of exercise called respiratory muscle strength training that requires a device to provide the resistance to do the exercise. There are current devices on the market. What we did was we identified some gaps in functionality. So we are working on creating a new device and a mobile app to add functionality to hopefully improve patient outcomes.
So I started like 10 years ago when I was a senior scientist in the cancer center. I realized there's a better way to really transfer the drug in a much efficient and less toxic, utilizing those biological materials. My research mainly focused on the very unique biological material that's secreted by the living cells. They're called nanobubbles, the actual cellular vesicles. We find that those biological materials are very biocompatible. They can be uptaken by cell very efficiently. So we should utilize as the very efficient drug delivery carrier to deliver drug in a much better efficient way. So we see this strategy can efficiently go on the clinical translation for the drug to be able to use and maximize the efficacy in treating the patients.
I came here to start the Center for Neurogenetics, which is a team science-based endeavor in which a group of investigators and collaborators that are really interested in repeat expansion diseases and how they work come together and work on this problem from different angles. These repeat expansion mutations that can cause different diseases like Huntington's disease, ALS, frontotemporal dementia, they are caused by expanded stretches of nucleotides that are repeated too many times. And in 2011, we discovered that something really unexpected and really controversial, and that is that these expansions don't behave as predicted. And there are a whole bunch of different proteins that can be made from these expansions. And so detecting RAN proteins, strategies to get rid of them, strategies to see if drugs are working by measuring the levels after drug treatment. And so that's what our inventions have been focused on. And I think it's been great to work with the team to brainstorm about how we can leverage that.
I'm a UF innovator.
I'm a UF innovator.
I'm the UF innovator.
I'm a UF innovator.